Okay, looks like we got a number of folks on the line here. Thank you all for joining. We're going to jump right into the webinar here today. So our topic for today is open materials functionality in 3D printers. My name is Alex Hussein. I'm the CEO here at 3D Chimera, and I'll be chatting with you guys about this topic. My background is mechanical engineering. I was one of the co-founders here at 3D Chimera back in 2013. And I'm very excited to speak with you guys about this topic today. New materials and, custom applications, that's exactly what we work on here at 3D Chimera every day. And we've got a lot of information to share. Specifically, we're going to go through some of the different types of materials, some of the different types of printers that we work with here, as well as some different applications, hopefully to get the creative juices going for you and see if we can help you to find a new application using these materials and perhaps some of the printers that we offer. So a little bit about 3D Chimera. We're based down in Miami, Florida. So if you're looking to get away and mix a little work in there, please come by for a visit. Here we have a number of 3D printers in-house. We offer 3D printing and 3D scanning services, as well as equipment sales. We do engineering and design consulting work. We do R&D work on that equipment. Generally, we really live and breathe 3D printing and 3D scanning. We're very proud that this year we're recognized as one of the top 10 3D printing consulting and service companies in the United States by Manufacturing Technology Insights. We're a small team based down in Miami, but we do work with a super broad range of customers. So you can see here from, huge multinational companies and universities to, smaller organizations and startups. Really the commonality between everyone here is that they're looking to do something unique with, additive manufacturing or 3D scanning. And we're able to help connect the dots and find some success with them. So we work with a wide variety of manufacturers and brands here. On the 3D printing side, the three lines that we mainly work with are the German REPRAP, the SINTRATEC, and the Time printers. As far as software goes, we work closely with the ANSYS Space Clean and Geomagic software. We work with HP on the 3D scanning side and lots of different materials companies, which you'll learn today. A couple of our favorites are Dow and DuPont, who we have a nice close relationship with. But really today our topic is specifically on open material 3D printing. Now, set some ground rules a little bit for our conversation. So we're definitely talking about industrial grade 3D printers here. So, we're not talking about like hobby level 3D printers and, things of that nature, but, how do we take advantage of an open material ecosystem with industrial grade 3D printing? So all of the conversations we're going to be having are about, machines that allow for some type of third-party material use, right? So these new materials are not going to void any type of manufacturer's warranty. They're not going to necessarily require any type of chips or ID tags or some type of proprietary shape or something to the spools. It does mean, though, that in order to have success here, that you have to have some basic material knowledge and design knowledge, some of which we'll certainly try to impart today. Really, the philosophy is similar to like today's CNC machine tools, right? So if you buy a CNC machine, you want to make a part out of aluminum, the CNC manufacturer isn't going to tell you where to go get that aluminum or that you can only use a certain grade, that they produce. Strangely, in today's 3D printing market, that seems to be like the status quo, that 3D printer manufacturers are telling people, you can print, let's say, ABS plastic, but only my ABS plastic. You can't use any others. We don't believe in that. As a company at 3D Chimera, we source machines that allow our customers to have access to the full open market. And fortunately, there are plenty of manufacturers out there that do allow you to have that level of decision-making and control in your manufacturing process. So one thing I want to highlight, though, is that open materials does not necessarily mean open source, right? So sometimes people think when we say open materials, they're thinking about like open source 3D printers, like you see on the left-hand side here. right? There's open source 3D printers are awesome, and it opens up the technology to the maker community and to young people who otherwise couldn't get access to it. But that's not really our focus today. What we're focused on are open materials printing, right? So these are going to be industrial printers that allow you to have access to that open material ecosystem, similar to what the open source technology allows as far as materials. But the open source is really like offering like free 3D printer plans, and like you build your own machines like bit by bit, sourcing stuff from Home Depot and maybe 3D printing parts of your machine. That's not what's happening on the type of technologies that we work with. So we'll get a little bit closer into that, but on the right-hand side here, you can see some of the printers from German REPRAP as well as SINTRATEC. These are all super precision crafted, pieces of technology equipment that allow you to produce really incredible parts that rival, 3D printers that maybe cost 5, 10, 15 times, the price points on these machines. And we're able to still have access to that full open material ecosystem. So they really fill sort of a unique sweet spot in the market, and we're very proud to offer this type of technology. So before we go too far into this, I'd like to open up a quick poll here that will allow you guys to answer some questions generally about your experience with 3D printing. So the questions are, how often do you use 3D printing? Where do you typically 3D print? If you print in-house, does your printer have any open material functionality? And then how often do you print with different materials? And finally, what are your most common 3D printing applications? So these answers will help me to guide the conversation a little bit. While you guys are answering, I'd like to say that as we go through here, please feel free to jot down questions, send over comments. I did forget to mention on the line, we also have Liz, who's our marketing director. She's going to help us out with our Q&A session, which will be mainly at the end of the presentation, but keep those questions coming as they come up. And certainly, Liz, if something seems relevant to the topic we're on at the moment, go ahead and flag that up, and we'll see if we can address that on the fly.
Will do. Thanks.
Okay, awesome. All right, so we'll give this about 30 more seconds here to vote. So if you have a moment, please click through there. I'm looking at some of the answers here right now, and I'm seeing how often to use 3D printing. It looks like everybody's using it either a few times a week or daily. Everybody on the line, it looks like, is printing in-house, which is great. It's kind of a split as far as open materials functionality. And it looks like folks are, sometimes or rarely working with new materials, not as often as we think, and exactly like we'd expect. The applications are across a really broad range here, so it looks like everybody's using it for prototypes, and mostly everybody's using it for jigs and fixtures. And then a few folks are kind of playing with the idea of tooling of functional parts and short-run production. So a really good range of folks on the line. That's awesome. So certainly I know that a bunch of relevant questions are going to pop out of this type of a group. So please feel free to share those as we go through. So 10,000-foot view here. The two technologies we're going to be talking about today are going to be the FDM FFF process and the SLS process briefly. So the FDM process is going to be where we start with a spool of filament. We're going to melt that out of the extruder, and we're going to build our object one layer at a time. This is the main technology that is utilized by most of the open material 3D printers on the market today, and hence will be the main focus of our conversation. The SLS 3D printing technology is a powder-based 3D printing technology. So you have plastic in a powdered form, it gets wiped over, a laser cures your part or melts that layer, actually sinters that layer, one layer at a time. SLS stands for selective laser sintering. So these are kind of the two core functionalities. Thinking about SLS in particular, I want to share a little bit about the SINTRATEC technology. Actually last month we did a webinar about the SLS technology. So if you haven't seen that, please let us know. We'd be happy to share that with you. We also have that up on YouTube, so you can check that anytime. But generally, what's really nice about the SLS technology is you can get super fine details on pretty small parts, and There are a couple materials available for that, PA12, which is a nylon, and TPE, which is a flexible material. Those are going to be like the main two materials that people are printing with in the SLS space. But there is actually like an emerging field of like open SLS materials. So I just want to touch on that a little bit. There's actually a really great case study that's getting quite a bit of press these days from a company out of the UK called FabRx. And FabRx is doing a really cool thing. They're actually sintering medicines. So they're customizing the medicines for individuals. So you can see some examples here on the bottom left. Of course, they're looking at shapes and things of that nature. But the main thing they're looking at is like dosage and size, right? Can we make a customized medicine, you know, for a certain size individual, a certain type of individual who needs a specific dose? So it's a really cool, really innovative idea. And they actually use the SINTRATEC Kit 3D printer here on the right-hand side of the screen. So, you know, that's one application where certainly in the open material capability in the SINTRATEC kits is showcased. We do have lots of folks who are actually currently, like right now, like probably they're on the webinar now and are going to go take a break in the afternoon and start working on custom material development again. And so, you know, certainly there's lots of folks out there who are working on new powders. The market for that isn't quite as broad today as it is in the FDM and FFF space, but certainly keep an eye on this. It's an emerging space and one that we'll be definitely talking about more in the future. So to focus on the FDM, FFF space, the main product line that we have in this space is going to be the German REPRAP 3D printers. Fundamentally, they have three models that vary in size, kind of like big, bigger, and like super giant, if that works. So a little bit later today, I'll actually hop into a live session and walk you around our shop here so that you can actually see those machines in person. And I'll show you a couple examples of parts that we print off of those. Here you can see a couple snapshots. These are just pulled right from our Instagram, but I wanted to highlight each of these because they really kind of showcase the broad range of materials that can be printed on these machines. So on the left-hand side here, these are some polycarbonate parts printed on our X500 3D printer. These are actually like internal components for a mechanism to actually drive a wheelchair. So it's super cool application, very functional parts. This is for like a one-off conversion on a wheelchair where, you know, producing injection molded parts just wouldn't have made sense. So that's actual end-use application there. In the center here, we have a carbon fiber reinforced impeller. So again, functional parts. On the right-hand side here, we have like this is like a fairing that goes actually on a window in a building here in Miami that kind of protects an opening from the rain and from the elements. This is printed out of a PETG material. In the left-hand corner here, we have some images of a part that we printed. It's kind of like a figure-8 shaped part here, like a chain link. And this is a vehicle we pull with that over 3,000 pounds. I'll share a little bit more information with you about that. So this is a glass fiber, I believe, reinforced nylon. Then here in the center, this is a project we worked on with National Geographic. There's a tortoise who happened to be unfortunately run over by a vehicle during one of our recent hurricanes here in Florida. And so we went out and we 3D scanned his shell and developed a new prosthetic cover for him. This is actually printed in PETG. So he can walk around in the elements and, you know, the sun and the rain, and the wounded area is protected. And it's pretty cool. You can see him, like, as soon as he had the shell on, he went out there and started like crawling in the leaves and burrowing in the dirt. And it was like he suddenly felt protected. It was pretty neat. And on the right-hand side here, these are just some like custom trophies that were printed, and these are done out of like a PLA plastic. So, you know, just right here on the screen, you're looking at, you know, 5 or 6 different materials that that were able to be printed through these open material systems. And really, that is the core strength of the FDM process, is when you can look at an application and choose, you know, not just the right material, but, you know, optimize the design and be able to use the hardware you have to achieve the results that give you the greatest flexibility in the system. So as far as materials go, there's a lot of vendors out there, and there's a lot that we work with. So, you know, of course, there's going to be materials from German REPRAP. They produce their own materials in Europe, and we carry a large quantity of those here in-house. So, you know, if you want to have the material from the manufacturer, that works great. Of course, those are always work. We have pre-built print profiles for all those. At 3D Chimera, we also have our own brand of PETG material at the moment. That happens to be like our favorite material to print with. It's very flexible in terms of applications, and so we always have that, and we actually make that on these super giant spools. So when we're printing huge parts, we have access to these giant rolls of material. But the 3D printing market is really changing, and specifically as far as the material space goes, a lot of the big players are really starting to enter the market. So, we mentioned Dow and DuPont, who we've been working with for years, but across the board, companies like BASF, DSM, and Solvay, traditional plastics companies are entering the space and really developing incredibly valuable materials for the market, especially specialty applications. So the types of applications where maybe you need a super high temperature material, or one that has very special strengths from perhaps some of their injection molding grades of material, those are available. And we're starting to see the emergence of even now specialty 3D printing filament manufacturers. So companies like 3DX Tech and Kimya and TC Poly, these guys are making like engineering grade filaments specifically for additive manufacturing. So they're not necessarily coming from an injection molding background, but rather have built their whole business on making these engineering grade filaments. So there's a lot of cool stuff happening in the materials space. It's definitely like an ever-changing landscape, and our customers are well prepared to be able to navigate that with whatever comes out. In fact, a number of folks on this list and on the following list here, which is a whole nother group of folks out there making filament, actually use German REPRAP 3D printers in-house to do their material development and qualification, right? And that's because when you're working with 3D printing, there's a lot of variables that come into play. Of course, you have the polymer itself, but just as important is the machine, and making sure that the machine is stable and predictable and reliable, so that as you're developing a material, for example, that you can trust that when you vary a parameter on the machine, that's the effect that you're seeing, that you're not necessarily fighting, let's say, a mechanical issue with the machine. So the German REPRAPs are known around the world for that, and that's why we've selected them and work with them as a partner. So, a lot of folks say, well, okay, this is all interesting, but, why open materials? And we say there's really three main reasons to think about. First is performance. Second is cost savings. And third is it gives you a lot more control over the process. And so I'll go a little bit deeper into each of these. So on the performance side, of course, having the variety, having the flexibility to use any material you want is valuable. It allows you to source hardware that at a lower cost, right? So you're able to take advantage of some of the open marketplace and economies of scale for components and pieces on the machines. And it also allows the materials companies to provide materials at a lower cost as well. So there's a lot of really interesting things that come out of performance side. Looking here at the material variety, this is kind of like a 3D printing version of the traditional plastics pyramid. So, down here at the bottom, kind of the most common, most available, and most widely usable across the spectrum of 3D printers out there are the PLA plastics. These are going to be a corn-based plastic. Prints at really low temperatures. It has a super low shrink rate. It's just all around a pretty decent material to print with. Of course, it has its own shortcomings, but it's pretty broad. And a lot of people who are new to 3D printing, this is one of the few materials that they work with. Then you have kind of this new tier, I'm going to call it the general 3D printing materials. These are going to have a lot of the benefits of the engineering grade materials, but also they're going to be much easier to print, similar to maybe the PLA material. So, PETG falls in here, the TPE materials fall in this category, as do some of the dissolvable materials like the PVA and the BVOH materials. As we move up the pyramid, the engineering grade materials are where a lot of our customers are focused. So these are going to be like your ABS materials, your polycarbonates, your TPUs, your PAs, which is nylon, your HIPs, ASA, polypropylene. These types of materials are commonly used in the industry and tend to be difficult to print on some of the low-end 3D printers, mainly because these materials often have a high shrink rate, and it's super important to have a very controlled print environment to make sure that there's enough heat surrounding the part so that that shrink rate is predictable and controlled, and that you're not fighting, the artifacts of what comes from a part that's shrinking, which are maybe like curling or cracking in your parts. As we move up into the pyramid here, our advanced engineering grade materials are really like super high-end materials. These are used in, the aerospace industry. These are used in applications where things like, having fire retardancy or other characteristics of that nature are super important, as well as like chemical resistance. So materials here might be like PPSU and PEC. You have PEEK, PEI, which is your Ultems, PSU. These types of materials are just starting to be able to be 3D printed today. At German REPRAP, we've had the capability to produce parts out of those materials for years, and I'll share a little bit more about that. And then there's this emergence of these specialty materials, which I alluded to earlier. And these are really cool, right? So these can be polymers that have, let's say, ESD properties, so electrostatic discharge, can be used in electrical applications, perhaps metal-infused polymers where we can actually dissolve out the polymer base and then sinter the metal together to actually get metal parts. There's actually a company out there that's making polymers that can be used for heat sinks, which is super cool, conductive parts, and parts that are reinforced with materials like glass fiber and carbon fiber. These type of specialty materials are really like pushing the game with 3D printing and allowing for applications that otherwise, even just a few months ago, a few years ago, were not even possible. So as you go up the pyramid, certainly the materials have better performance, but of course, there's complexity that comes with that, right? So it's important to consider that, and that complexity of printing often comes down to the type of hardware you have available and how capable it is. So, a lot of times people say like, well, what's just the best material? Like, what's the best material out there? Right? There's all these different materials. Just tell me the best. Is it the one at the top? And that's not necessarily the case, right? There's so many mechanical characteristics, right? Stiffness, strength, temperature resistance, chemical resistance, impact resistance, the hardness or durometer of the material, maybe the flexibility of the material, perhaps its ability to withstand pressure. All of these types of mechanical characteristics can be measured for some given standard, perhaps an ASTM standard or some other information that lives on the spec sheet. But your usefulness of these characteristics is completely dependent on your end application. So, performance is always some combination of these material properties, but also really understanding like your part design, right? DFAM for us is designed for additive manufacturing. Optimizing your part to take advantage of 3D printing capabilities and additive manufacturing's constraints, so that we can build parts that are able to have the best possible set of parameters. And then finally, the actual printer itself, the settings of the machine, those are able to be manipulated and varied, right? And so if you don't take advantage of those, perhaps in like the right combination, you can also have a material that has great specs on paper, a design that's been optimized well, but you can still have bad results. So it's really this combination of things, and it comes back to our idea of connecting the dots, right? So you really have to put all of this together in order to have success moving forward and really trying to get that type of performance. So secondarily is saving money, right? So it's important, of course, to think about the bottom line in any type of application. And what's really cool about additive manufacturing is that we have this wide variety, right? So once you've sort of honed in on a particular material, the market is open. So there are new companies coming out every day. That type of competition helps to drive costs down. We see that open materials can be anywhere from 25% to 80% less expensive than materials that are used on closed system 3D printers. They're also often significantly better in terms of mechanical performance. So it's like they're cheaper and better, which is not a super common combination. But it is important when you're looking up materials to make sure that you're comparing apples to apples, because particularly these closed material printers, they try to be a little tricky about their pricing. So maybe they share their pricing by volume, or maybe they share it by weight, or maybe they share it by spool, right? But at the end of the day, like you have to look at it like per an even unit, right? So if you're looking at, let's say some type of an open material, make sure that you're really getting down under the hood and understanding precisely what characteristic you're measuring that on so that you can get a good cost comparison. But a general rule of thumb, you're always going to save material on the open market as compared to a closed printer. And it's usually going to be very significant. But also important, not all plastics are going to be created equal out there, right? So quality still matters. So just because you can buy material on the open market, that doesn't mean that we want, to necessarily go on Alibaba and find the cheapest possible spool out there. You do want to work with the trusted brands. You do want to make sure that you're going to have some reliability and some repeatability behind that material. So, when it works well for your first application, you'll be able to buy it, this year to produce your first 100 parts and next year to do your first 5,000 parts and the year after, across your whole print farm. So you can do, 10,000 parts. You want to make sure that that material is going to be around and that it isn't just some fly-by-night operation. So there is a balance there, but regardless, even the big players, the materials from, the Dows of the world, the DuPonts, the BASF, those are still significantly less expensive than what you see on these sort of proprietary closed 3D printers. And the final reason is, having these open materials gives you just more control over the process, right? So, I'm an engineer by training. I always want to make sure that I understand all the parameters of what I'm working with and be able to take advantage of its strengths and its weaknesses. And that's precisely what an open material 3D printing environment allows you to do. You can control every possible detail, right? All the print parameters, how the materials are prepared prior to printing, post-processing, the whole thing. And that's what allows you to push the boundaries of additive manufacturing, right? So we try to help our customers not just print parts, but actually solve a major business problem by implementing additive. And so whenever we can find an application where we can do that, that's where we find our customers are really finding the greatest value in working with our team. So certainly, as you are looking at applications out there and thinking about new materials, remember that, as you're thinking about a printer, at least, you want to make sure that you've got access to that sort of capability to have more control in the future. So, of course, like anything, there are lots of considerations. So certainly the extruder temperature is one, the bed temperature is another. The chamber temperature is a huge one, and one that's pretty interesting because most 3D printers have a totally open environment, so they have no chamber control. They don't even have a chamber. And then, some printers have an enclosure, but they have no active heating. And there's like a super tiny handful of printers out there that have full chamber control. One of which is actually our German REPRAP X500, which is, I'll get into that in a moment. But certainly that's one that gives you this really broad range of capabilities. And then just as important is the hardware and the mechanics of the system, right? So you want to know, how is the machine built? Is it going to be stable? Is it going to be predictable? And what type of extrusion system do I have, right? Like, how am I pushing this material out? For example, if you have a flexible material or a stiff material, those might have some different requirements. So we'll cover these in just a moment here. So as far as temperatures go, just looking broadly across the German REPRAP lineup here, what you'll see is across the 4 printers, we have pretty high temperature range on all the machines. But the 500 is really like exceptional, right? So where we're close to about 300 degrees on the 400 and on the 1000, the 500's up here all the way in like the 450 range, right? And that's on the extruder. The chamber itself is actively heated on the 500, so we're getting that up here well over 100. And the bed, similarly, we can get this, up in the 150 degree range. This kind of range of parameters here, you'll find is like super unique on the marketplace, really across all the machines, but certainly on the 500. And it's that technical capability as far as the heating goes within this really rigid frame and completely enclosed environment that allows you to print these new engineering grade materials and have massive success with it. Going back a little bit to the hardware mechanics, of course, there's the obviousness of like how robustly the machine itself is built, right? And you can see these things are built like a tank. But just as important is like some of the subtlety in how the components on the machine are built. So all the German REPRAP machines are going to use what we have on the right-hand side here called a direct feed extruder. What this is that basically you have the drive wheel for the printer that's going to be attached to a motor, and sometimes an idler pulley or a second gear here, pushing the filament right out of the hot end, right before that hot end, right? There are other machines that use something called a Bowden extruder. What a Bowden extruder does is it like has the motor separated from the hot end of the printer, and it kind of pushes along a big tube, you know, right out the hot end. Now, there are some advantages and disadvantages to both, but if you're looking to do material experimentation, you really want to have a machine that has a direct feed extruder. This way you can control the process right at the nozzle tip of the printer. If you have it remote, you can deal with all sorts of things like buckling and extra friction in the print line that can make it really difficult to try and work with some of these new experimental materials. So, you know, as you're out there looking, it's sort of like a subtle feature, but I think what you'll find is that the higher end the printer is, the more likely it is to have a direct feed extruder. And on the lower end side, you'll see a lot of the Bowden extruders. These tend to be a lot less expensive. The machine can be a lot less robust in order to push the filament from a fixed location than to have all that mechanics moving around right with the hot end. But this is key to get good results. So by way of example here, I'll share a little bit about two of our favorite materials from DuPont. So this here is our carbon fiber ZYTEL material. This particular material is one of our most exceptional materials as far as performance goes. It's super stiff, so you know, compared to nylon, let's say it's like 3 times stiffer. So just by adding the carbon fiber, the glass fiber, we're able to get that extra stiffness. It's about 2.5 times stiffer than like an ABS plastic. As far as like its strength, its ultimate strength, it's 2 times stronger than regular nylon or 3 times stronger than ABS plastic. And it's also great at high temperatures, right? So this is stable up to about 166 degrees Celsius. The glass fiber versions, I think, up over 170 degrees Celsius. So, you know, in these scenarios here, you're looking at, you know, about 2 times hotter environment than just a regular nylon or an ABS. That's really important because suddenly now your parts can go from, let's say, a prototyping application to end use, right? So we can pull vac form parts over the top of this. These can go in under the hood applications. These are actually the same polymer base that's used actually in lots of automotive parts today, right? And that's the power of partnering with an organization like DuPont. So this is another close-up of that part we were looking at here. There's a video of this guy that you guys can look up on our Instagram or on our YouTube account. But actually, we were able to pull this vehicle here, you know, with this 3D printed part in the middle. It's like about a 3,000-pound vehicle. So it's a very cool application, and you know, goes to show the power of, you know, simple design with the right materials can do really incredible things. So another material that I'd like to share with you guys is the DuPont HYTREL material. This is a TPE material available in a 60D and a 40D durometer. So these are really great materials as well. What's really interesting about these is that the parts themselves were tested by an independent lab and found to be at equivalent or even better strength characteristics than injection molded parts. Now that is super rare in the additive manufacturing world, and it goes to show, again, the strength of working with a partner like DuPont, who has polymer scientists who actually understand the process, who aren't just grabbing pellets off the open market and turning them into spools, but are actually, you know, developing purpose-built 3D printed materials. Some pretty incredible stuff can happen there. So, you know, we work with lots of organizations. Some of the world's largest shoe manufacturers, for example, use these materials in our printers to build, you know, prototypes of their midsoles, for example, before they go to market. So hopefully that gives you guys like a brief overview here of the German REPRAP technology in general, as well as some of the advantages of the open material characteristics of the machines. What I'd like to do now is jump into a live demo. So I'm gonna stop sharing my presentation screen here and just leave it on the video, and I'm gonna walk you guys around and show you a little bit of our shop here. All right, great. Liz, can you confirm, or are you guys able to see the video okay here?
Yep, looks good.
All right, so just let me know if this goes out. It's gonna get a little choppy because I'm gonna be walking around. All right. So this is our the front entrance of our office here. You can see actually there's some of the SINTRATEC machines up in the front. We'll just kind of spin around here. You actually see there's the larger SINTRATEC machine. This is the SINTRATEC S2. But what I really want to show you guys today are the German REPRAP printers. So here we have actually a new version, which is the gray one here. That's the German REPRAP X400. And actually one of the old original versions of the German REPRAP 400 is in the corner there in blue. So we'll talk a little bit about the new version, the version 4 of the X400. So right now, let's see here. I think, yeah, we don't have this guy printing right now, but I'll give you an idea of the size of the part that you can print, right? So pretty large pieces. This guy's probably about 12 inches in height, maybe about 10 or 11 inches in diameter, and super strong. So you definitely can print big functional parts on a machine like this. This particular part happens to be made out of a PLA material. And, you know, it's a great example of what you can build on these machines. So give you guys like a quick tour here. So, you know, the 400, it is a super well-engineered machine like you might expect from any German product. So you've got a touchscreen display there, of course. Inside the machine, you're going to have lots of like engineering grade components, whether they're belts, pulleys, motors. You can see up in the corner on the right-hand side, that's the extrusion system. That's made out of a machined aluminum system. You got filament out sensors, filament tracking systems, really all the features you might expect on any type of a professional 3D printing environment, you're able to get with the X400. And that's the entry-level system from German REPRAP. So I'm going to go ahead and head into the back of the shop here. All right, as we head back here, you can see both the X1000 there in the corner as well as the X500. We also happen to have this heavy bag here in the back. I'll go ahead and point something out to you guys really interesting. So up at the top here, you'll actually see we've got one of those 3D printed rings I was telling you about actually here holding the heavy bag. Now we produce these parts a lot, so if you are interested in getting your hands on one of those guys, we have these in stock all the time. I'd be happy to send one out to you. We're yet to find someone who can break one of these guys. But you can see it's a pretty small part, and we're able to produce these super strong features out of something super small. It's also crazy durable. So, you know, not only are we producing a strong part, you know, this took, like when you see the video, this took the impact of a truck pulling it from a full stop, and it didn't break. We've had people throw these across the room, throw these at concrete walls, and they seem to withstand all the damage. So it's pretty cool. All right. So we'll head back here. I'll show you a little bit about the X1000. So the 1000 is our biggest 3D printer. So, you know, you can kind of get an idea of the scale there. In here, you can see a pretty huge build environment. You know, you can use it for lots of small parts, or you can use it for like one giant part, whatever makes sense for you. I'll show you to give you an idea of scale. You saw all those pieces in there. This is a huge part, right? Like, I don't know, this is like 16 or 18 inches in diameter, right? It's even hard to get on the screen there. So, you know, you can definitely print enormous pieces on something like the X1000, which you'll see. All right, are you guys in? I can now, yeah, sorry about that. Can you hear me?
We sure can.
All right, cool. So you guys lost a little audio on there, huh?
Yeah, if you could ask it. It was lost around the time you were showcasing the piece that came out of the X1000.
Oh, okay. All right, no problem. So what I was saying is that it was like a pretty huge part. Sometimes it's a little difficult to get an idea of the scale here on the video, but you can see this is a pretty large piece, something like maybe like 18 inches in diameter. And then I believe I was just showing a little bit about the X500, which is the printer that we have here. It happens to be printing a part right now, so there's not a whole lot that I can show you guys, but the main thing is that, you know, it has very similar to the X400, lots of the industrial features. So, you know, you got your touchscreen display, network connectivity. You've got the, you know, the machined aluminum extruders inside. You have actually a fully heated chamber on this machine. So you have lots of different types of capabilities with the machine like the X500. And, you know, all the German REPRAP machines across the board are built to a pretty high level of quality. So maybe now would be a good time to open it up for questions. Did you have any questions come in, Liz, while we were working on all this?
Yeah, we have a couple of questions, and so
okay.
I'll throw those over to you, Alex, and any new ones that come in. So first one I'd like to have you field is, how many FDM materials are currently available for this class of printer?
Sure. Yeah, that's a great question. So, you know, right off the top of my head, I wouldn't know the exact number. You know, I think in the presentation we had, it was something like maybe 15 materials right off the top. But what's nice about the 500 is, and I literally mean this, we have yet to find a material that we can't print on this machine, right? Because of its temperature range and because of its control on the system, we're really able to produce parts out of just about anything that comes our way. So, you know, I have some examples here. This is one of those flexible parts made out of the HYTREL. Right, here's another one with a slightly different durometer. A little hard to see, but you can see it's not quite as squishy on that guy. Right, so you can produce flexible parts. Here's an example of you know, a super strong part. This is made out of carbon fiber nylon here, pretty much like unbreakable. We even did a part where we made a whole 3D printed skateboard. This thing actually can hold me. So you can do lots of different types of materials on the German REPRAP printers.
Great. And what other companies outside of the ones you showcased are developing materials for these open system printers that are maybe still in development, that are on the horizon or in the pipeline?
Right, I gotcha. Yeah, well, I would say that, you know, basically every major plastics company is working on 3D printable versions of their polymers. So there's probably not a week that goes by that we don't have like some major materials manufacturer reach out and either share new materials or, you know, extend an offer to collaborate on developing new materials. So in some cases, they're trying to enter the more basic level of the market with, you know, an offering to the general public. In other cases, they're looking at super specialty applications where they can really take advantage of all the R&D and tech that they've built into their base polymers, and they want to, of course, enter the new realm of manufacturing with 3D printing and additive manufacturing, and find a way to really work in that market as well.
Great, thank you. Okay, so another one we have is, why do some of the major vendors, for instance, Stratasys comes to mind, stay with a closed system as it refers to materials? Sure.
Well, I mean, certainly there are some advantages to a closed system. So probably the biggest advantage in a closed system is that, you know that you're going to get a predictable result out of the system, right? It takes some of the variability out of it. So I think a company like Stratasys or some of the others that work in the closed material setup, they're really looking for having that predictable and reliable print happen every time out of the machine. And there's certainly some value in that. The way that we look at it is that as long as you have material sourced from a known vendor, then you can achieve the same thing. So, you know, let's say, you know, you wanted to print ABS parts, if you're sourcing German REPRAP ABS, which we know is excellent quality, and we have a pre-built print parameters for that, you know, it's basically also a one-button print, but you have this flexibility to kind of do whatever you want. You know, it's hard to say exactly why some of the other big players haven't recognized the value there, but you know, what we know is that our customers, specifically those at 3D Chimera and more generally the German REPRAP customer, they're really looking for that capability of having flexibility in the system and having control, and they don't want to feel constrained, you know, into some ecosystem that they really have no control over. So, you know, if they buy a machine and then are locked in, and then let's say the vendor raises the price on the materials, then they're stuck. That's not the case with German REPRAP.
Great, thanks. To further something you just said, we have a question about the functionality. So are these new materials for these open systems of the load and print variety, or is there more setup, more steps involved to print these various materials?
Yeah, so it's gonna go across the range. So if you source a material from 3D Chimera, then those materials are all going to have pre-print or pre-prepared print parameters ready to go. So we don't sell anything here, whether it's a machine or software or materials, that we don't first test, optimize, and really fall in love with at 3D Chimera. So anything that's bought from us, you'll have a pre-made print profile, so it's as close as you possibly can get to dropping the material in and hitting print. Then for more experimental materials, it does take a little bit more time to optimize the print parameters. We do offer a service here at 3D Chimera for customers who maybe they don't have the resources in-house to do that. We have a service where we can help to optimize the print parameters for any given machine, let's say from German REPRAP, but really any 3D printer. And then that way our customer can kind of hit the ground running. So we try to fill the gap wherever we can provide the most value. Of course, nobody wants to spend all day, you know, messing with the printer, but you know, sometimes that's necessary when you're doing something that no one's ever done. So, you know, for example, the guys who have developed these polymers that are able to operate as a heat sink, you know, those take a little bit more time to make something like that work than let's say simply like a carbon fiber reinforced material.
Excellent, thanks, Alex. I think I've got one last question here for you, and any others that come through, we can always follow up with you after the fact. And feel free to email us with questions as you think of them. So finally, what software do you use, or 3D Chimera, to prepare the models for printing and controlling the printer?
Gotcha, yeah. So from a design perspective, you can use like any CAD software. We happen to use SolidWorks most of the time here. Sometimes we use SpaceClean. But from preparing the parts for printing perspective, usually that software is unique to the printer. So in the case of the SINTRATEC printers, there's a software called SINTRATEC Central, which is basically it's the slicer. That's really, I think the software we're talking about is called Slicer. It's the slicer for the SLS 3D printers from SINTRATEC, and it's going to allow you to tweak all the parameters and temperatures, speeds, etc., and set up your part for printing. On the German REPRAPs, we use a software called Simplify 3D, which is kind of a cool software. It works with a lot of printers. We call them G-code based printers, or really any type of printer that literally is using G-code to drive it. You can use something like Simplify 3D to prepare the parts for that. So it's a nice flexible software, and that's what we tend to use for that.
Great, thanks, Alex. I think we've covered all the questions that have come into us during this webinar, so I turn it back to you.
Okay, cool. All right then, so I'll just go ahead and share my screen once again here. I want to make sure that everybody gets an opportunity to see my contact information here up on the screen. Certainly, you know, don't hesitate to reach out to us here at 3D Chimera. We're happy to you know, have a live demonstration with you if you would like to come down here with your team. We of course visit customers all over the state and all over the country who are interested in 3D printing. We can do that in person. We can do that over the web. So you know, my contact information is here. That's my direct phone number. Don't hesitate to reach out. That's my email address. So We'd love to stay in contact with you guys and help out with whatever application might be coming your way. So with that said, I'd like to thank you guys all for your time. Certainly, Liz, thank you for your help. And we look forward to working with you guys in the future. Thanks a lot.